Hi, this is Raisa Riches with Browning Math, and we will be talking today about transformation of functions and families of functions. To be more specific, if you have a family of functions, y is equal f of x will be the parent of the family, and g of x would be kind of the members of the family, which are results of transformation of this function. Transformations include horizontal and vertical translation, and vertical and horizontal stretch and shrink of the function. I'll just show you what this presentation includes. If you want to use it or play more with the parameters of the function and learn how they change the behavior and look of the function, you can download the whole file. This is Geometry Sketchpad 5 file, and you can download it from this address. So we will start with linear function. Linear function has a parent y is equal to x, and let's see how this function can be transformed. Right here you can see the result of transformation. It includes multiplication of x by the slope and adding y-intercept b. So this is slope-intercept form on linear function, and let's see how parameter a is changing this function. So when I increase my parameter a, function becomes graph becomes more and more slope. If I decrease my a function is less and less slope, and when a becomes negative, we actually instead of increasing function have decreasing function. So we can see exactly how it changes an equation by showing equation itself. So one more time, if I change here my a, so right here you can see the change of this parameter and see how it influences the behavior of the graph. Right here you see y-intercept that also can be changed, and y-intercept translates our graph up and down horizontally. So this is what you can see on this portion of the graph. You also can see here the inverse function for this linear function. We know that every point of inverse function is a reflection of every point of initial function over the line y equal to x. So right here I'll pick point x that belongs to the function, to the linear function. I'll be moving it, and you will see that the blue point is a reflection over the over the line y equal to x, and you will see that the blue point, if we trace it, will draw us the line of the inverse function. So this is what you can do with this portion of the graph. Let's move to absolute value function. Absolute value function with a parent y equal to absolute value x. Its transformed form looks like this: g of x is equal a times absolute value x minus h plus k. Let's see what will happen if I start playing with the parameter a that is right here. So here as of now, my parameter a is equal to pretty close to 1, it's practically 1. So now I will increase this parameter. It stretches my function vertically, and if I decrease it, it apparently shrinks my parent function. When a becomes negative, we will have a reflection of the function over x-axis. Now let's see what happens if I change parameter h. Here is the change of parameter h. In fact, this parameter h is dragging our function left and right, and parameter h actually is the first coordinate of the vertex, of the new vertex of our function. If I play with my parameter k, you will see that this is where it sits in the transform function, and this one is in charge of vertical translation of the function, and it also gives us the second coordinate of the vertex of the new function. And of course you will be able to see how inverse relation will look like. So here is my line of symmetry, And let's find where is my point that here is my point on the graph. So if as long as I move this point, I will see that reflected point actually sketches the graph of the inverse. In this situation, it's not a function, of course. In our situation, this is an inverse relation. So inverse for this one isn't a function, but you can clearly see how they are related. You can do pretty much the same things with a quadratic function. In quadratic function, again, coefficient a is kind of sort of relative of the slope. So as long as a becomes bigger, our parabola becomes more and more narrow. As a becomes closer and closer to 0, our parabola is more and more open, and when a becomes negative, the whole parabola reflects over the x-axis. So this is what's happening with the parameter a. Parameter b, again, parameter b is the one that is responsible for the horizontal translation of the function. It shows us how the first coordinate of the vertex is changing. So we try to put it somewhere here. Well, maybe I won't. So here is my parabola traveling left and right, and parameter k is responsible for the second coordinate of the vertex of the function. So it goes up and down. Again, you can see the inverse of the function by clicking on the point show inverse, and if you track the function, you will see the inverse relation of this function. The same thing you can do with cubic function. You have an option of exponential function. You can see the trigonometric function sine function, which allows you to play with the amplitude of your function, with the vertical shift and a horizontal shift, and see inverse also. The most interesting will be the very last one, is the power function. Power function that has a parent y equal x to the nth power. N is a parameter that you can change here, and we pretty much were talking with you about quadratic function, cubic function, fourth degree function, but we never discussed yet what is this n becomes negative. So if you have n equal to -1, you have an inverse power inverse variation, and let's see how you can play with its horizontal and vertical stretch. So this is your vertical stretch reflected by this coefficient in the equation. Let's look on the horizontal, excuse me, this is vertical. On the vertical translation, see the function translates together with its vertex, and you can see here its coordinate, and we also can change the horizontal coordinate of the vertex. So this presentation shows you how the power function reacts on transformations, and power function includes power function with n equal to any integer number. So you can see what's happening with n goes from even to odd, and what's happening when it goes from negative to the positive. The second set of the presentations that is presented here has the same name that previous one, with addition linear. So linear transform. What this presentation allows you to do: first of all, it allows you to move function itself and see how it changes parameters, versus changing parameters and see how the function reacts. So here is my vertical translation, and you can see what parameter is in charge of it. It sits right here, and so you can physically drag it up and down and see the change of the graph and change of parameter. You also can change the slope and see how it changes an equation of this function. If we go ahead to absolute value function transformed, here what it allows you to do, you can pick the vertex and you can move the vertex around and see how the coordinates of the vertex are related to the parameters of your function. So here you have the coordinates of the vertex, here you have parameters of the function. Of course, parameter A is still in charge of the vertical stretch. But again, here you can physically move your function around and see what's happening with the equation. The same thing you can do with quadratic function. Let's make it up and down with the first coefficient negative, and this is how you can move. You can translate your function any direction you want, and you can observe what's happening with the with its parameters and with the coordinates of the vertex. Power transform function, again you can pick any function, any power function you want. Gives you a lot of freedom of picking what you actually want to play with, and you can pick the vertex and you can translate your function, delete it, and see how it changes parameters. There is one page here that is called play function. Play function, for example, this is the function that I entered. It's logarithmic function that is transformed, and this one shows you it's actually composition of quadratic and logarithmic function, and you can actually play with parameters and see what they do with the function and observe the common pattern that relates it to the transformations we saw on the previous pages. In case you want to look at something different, you just double click on this function, and for example, instead of squaring logarithmic function, I will take here the square root of it. I will take a square root of this function and see what happens. So you can see that graph changed, and that's kind of not really interesting one, but you can see how this one also reacts on the change of the parameters. It's all about stretch and shrink and horizontal movement. So again, if you want to play with these functions and learn how they react on the change of the parameters, you are free to go to http bitlu trans function and download the file and play with it and learn everything that you need to know about families of functions. The very last one, I didn't mention this one. This is the change of sine function shown a little bit differently. So it depends on what you actually want to learn. You can refer to two pages here with sine functions. This is particularly page that allows you to see how period is related to frequency and count how many periods of transform function make the standard 2 pi period of the sine function. Again, here is the URL that you can go to download the file, and thank you for your attention.